Welcome to Deep Engineering's YouTube channel, where we bring you real-world insights from the architects, engineers, and authors shaping modern software. Today, we are speaking with Amar Akshat, SVP of Architecture at Paysafe Group and author of the forthcoming Decode the Compiler book with Packt Publishing. Amar leads AI-native modernization across payments, wallet, and compliance platforms at Paysafe, and previously helped shape the architectural foundations of Apple Pay, contributing to Apple's global wallet and tokenization frameworks. His work focuses on making architecture itself intelligent, blending principles like CAP, 12-factor, and zero trust with AI-driven reasoning and automation. And he's also behind Paysafe's internal MCPX agent exchange framework for AI-assisted developer and business workflows. And he's here with us today to talk about how agentic systems and cell architectures are changing how we design, operate, and scale modern platforms. So, a very warm welcome to you, Amar. Thank you for being here with us today.
Thanks, Divya.
I'm really looking forward to this conversation. So, just for context for our viewers, can you give us a quick overview of your current focus areas at the AI architecture intersection? What lens do you think we should use today? Should it be compiler-centric, system design, or product architecture, and why?
Sure, thanks. Thanks for the introduction, Divya. Right now, my focus is what I call agentic architecture, designing systems that can reason about themselves. So at Paysafe, that's embodied in the MCPX, which you talked about. And we have something else called ArchX or ARCHX, which is basically a AI native workflow that powers things like onboarding, fraud analysis, observability, but also reasoning with systems and their own capabilities. Like you mentioned, zero trust, like you mentioned, the CAP theorem. A lot of what we do today is about codifying architectural experience. For example, we have trained internal AI agents to analyze architectural design records or ADRs and suggest reusable design patterns, effectively learning from the scars of every project before it. Right? So, and when you talk about lens, it's an interesting analogy you use with compilers and system design. I would want to use the system design lens. You see, architecture isn't abstract for me. It's very progressive, it's very pragmatic, and it has building blocks like servers, data, flows, queues, failure domains, right? And my work sits between things like compiler intelligence and distributed systems and their logic. So if you think about it, the compiler is just an early architect. It takes intent, it optimizes it under constraints, and produces an executable structure. And that's the same mental loop I want our AI agents to have when designing complex systems through architecture.
Yeah, that's brilliant. And I think you are probably one of the best people to ask my next question to, because you sit exactly at this intersection, which I think a lot of people are still trying to make sense of. So where does AI practically help architects now? And where is human judgment non-negotiable?
That's a great question. And I get this asked a lot in my team as well. So we have tools like Cursor, for example, or Replit Agent 3 or GitHub Copilot Workspace. They basically act as junior architects today. They help me generate documentation. They suggest failure patterns from known premises and known previous experiences. And they help me validate deployment diagrams. For example, every good generative AI can create brilliant mermaid diagrams, right? So it can start off as your starting whiteboard where you throw in your constraints and components, and it will start with a basic mermaid diagram that would take an architect a few hours to actually come up with, right? At Paysafe, we are using AI during architectural reviews. So it will ingest our ADRs from before, diagrams and code bases, And then it will flag inconsistencies, right, between what we said we would build and what we actually deployed, right? Because it has the whole lineage of design from scratch all the way to deployment. So it can reason and tell you with evidence that this was the original plan to be deployed, this was the scale pattern, and what we ended up deploying. Human judgment, on the other hand, still owns context, risk appetite, regulatory nuance, and product trade offs. The politics between product and regulatory, right? That is all still owned by human. And the AI can propose, but humans prioritize, right? I know that my business can reasonably make money in EMEA and Europe for now. So I will prioritize regulatory nuances of EMEA and Europe and then put through my roadmap what will come in Americas, right? So that is the beautiful mix between how humans and AI interact in architectural designs.
Yeah, that's brilliant. And I think we are going to talk a little bit about the regulatory context a bit later. But right now, what is your current mental model for deciding when to put AI in the loop versus keeping a purely deterministic path?
Yeah, so if the task benefits from pattern recognition, you know, like finding performance bottlenecks or suggesting cell boundaries, we use AI, right? If it requires legal, financial, and compliance certainty, we keep it deterministic, right? And I think of AI as an intuition layer, not the execution layer, right? And intuition basically is around what kind of data are you dealing with. AI can look at the data patterns and say, oh, this is PII slash this is PCI, right? These are the compliance guardrails you will require. This is the right pattern because of the scale factor, right? What kind of caching to use because how many times the AI APIs are being called, etc. So it gives you that intuition, but the execution has to be more deterministic, and that is where we sometimes do not use AI.
Right. Now let's talk a little bit about architectural patterns for AI systems. What baseline patterns have proven reliable for shipping AI features in your context, and where have you found them to break?
Yeah, so that's a good question. So baseline pattern if to ship AI features, I think is three-dimensional for me. You can imagine it has three postulates. One is the data postulate, the second one is the guardrail postulate, and the third one is the system prompt package itself. Right? So when I say data, I mean your static policy documentation, your static understanding of systems, etc., and dynamic data, which can be made available by MCP servers, right? Such as transactions, such as user records, addresses, etc. Guardrail is about making sure what is allowed to be done and how much prominence do you give to autonomy, right? Do you want to completely ground the system? Do you want to have fairly only deterministic responses, or do you want to use the experience and intuition layer of AI, right? And the prompt package is all about formats, right? Here is my execution format, here is my input format, and what am I expecting the results to be in? And what are the other nuances I do want my system to take care of, right? And with these three things, the model works best. So we use things like LangChain and OpenAI or Azure's AI Foundry for RAG. And we have our own prompt manifests for governance, right? So everything runs through an AI, so through an event-driven backbone. So you can imagine things like Kafka plus Fast API, right? And each inference of it is observable. So you can actually observe the output coming out of these models and determine the reasonability of them, find out their accuracy, etc. That is the current model which works for us. Where it breaks is things where, as I was saying, execution is critical. For example, if latency is critical, right, then you cannot rely on LLM, for example, right? If user experience is critical, if things need to be made quickly in a judgment fashion, then you cannot rely on LLMs. Then we deploy lightweight sidecar models, right? Things like OpenAI Mini or Llama 3 Local for shared and fast intelligence, right? But when it is things like even fraud scoring, which has to be real time in a transaction, we try to do these things in a centralized fashion.
Right. And how do you decide boundaries for AI components, such as separate services, sidecars, or embedded libraries?
Yeah, that's a good segue from the previous question. So it is all, I call it an architecture based on cells. So cell is a human component, which is the tiniest unit of life, right? So all of our AI deployments are tiniest units of life with its own regulatory nuances within themselves, right? So for example, if I'm talking about wallet, right? Everything which can support wallet, its guardrails, its prompt package, its MCP servers, RAG, plus its fine-tuned models also will participate in that cell, and it won't leak any data, right? So the idea is the critical path of analysis never leaves the cell boundary, and it only leaves the cell boundary for audit and storage purposes. But the critical path of analysis never leaves the cell boundary. That keeps us safe, first of all, fast, and then deterministic. No other data is going to change the way my wallet cell behaves, for example. Same thing applies to payment execution. Same thing applies to transaction ledgers, so on and so forth.
Right, right. And now let's talk about modular monolith versus microservices. So, when would you favor modular monolith over microservices for AI and vice versa?
Yeah, so I think if shared memory and stateful context matter, like a conversational commerce system, a modular monolith will, with well-defined internal modules, works best, right? So two people asking about what to buy in Diwali, right? Across India, but their shared experiences and shared portfolio product matter. That's a great place to have well-defined internal modules in a modular monolith. If scalability and isolation are paramount, right? Example, fraud detection, right? Microservices will win because AI workloads often oscillate between the two, right? And many of us, we call it context isolation trade off, right? What is more important for you? Is it context or is it isolation?
Right. Brilliant. Shifting gears a little bit, let's talk now about reliability, safety, and testing.
Mhm.
How do you design for correctness and failure isolation when models are non deterministic?
Yeah, so we route by confidence, really. So if the model's output confidence is less than a threshold, it escalates to a deterministic rule-based system, or we will bring a human in the loop, right? And we use things like Lang-Smith and internal logging to track trust deltas per request, right? We have effective guardrails and fallbacks. So prompt validation, schema enforcement, like we use things like Pydantic. We are a big Python shop sometimes for AI-based workflows, and we use Pydantic and semantic sanity checks. So human only steps in for logic failures, not syntax, really, right? And we have comprehensive testing strategy for AI features. For example, one of my cohorts, they run drift pipelines, right? So they will daily evaluate comparing outputs to goal data sets, right? Goal data sets are those data sets that are deterministic and known to be correct, right? And any semantic drift triggers a review. And basically, you have to look at AI prompts as code. That's it, right? So our CI/CD basically treats prompts as code. Every change goes through the peer review process. It has automated regression and some kind of sandbox deployment to test these against the goal data set, basically.
Right. And you mentioned guardrails and fallbacks. So if I ask you to just distill down to a couple, what guardrails or fallbacks or human in the loop steps have been most effective in practice?
Yeah, so in terms of guardrails and fallbacks, first of all, as I was describing before, guardrails are learned. We learned these guardrails from execution. So every prompt package has a version, and with every new execution and failure, we put in more guardrails. For example, if it ended up putting someone's email address from the RAG into a response, which was meant to be PII sanitized, we will again augment the guardrail to have that sanity, right? And those guardrails are implemented by tools like prompt security, which will ensure that none of these guardrail filters let you pass the data back onto the customer, right? So on and so forth. So if you apply a middleware kind of a concept like prompt security or any of those use cases where you can apply these guardrail policies before the prompt goes into the LLM and the response comes back to the user, you would have effectively masked your failure pattern. And human in the loop is usually very important when the response quality. So every response has a confidence score, right? And if the confidence score goes below a certain threshold, human will come in and try to analyze what was wrong. Was the data too noisy? Was there too much guardrail or too less guardrail? Or was it a format problem, right? Did we come back with bad formats, right? Something break in the CI/CD somewhere or changes, etc. So the combination of middleware components like prompt security and usage of guardrails as a human is very important.
Right. Building from that, can you describe a sensible testing strategy for AI features covering eval, data drift, and regressions?
Yeah, so I think the testing strategy goes for AI systems goes hand in hand with observability as well. It's always a loop because you are learning from what went wrong. It's just like how humans learn, right? We learn from our mistakes. Similarly, we have to make sure the AI learns from its mistake. But so idea is that we have to monitor things like latency, cost per successful inference, etc., semantic drift, hallucination rate. You have to monitor them with real world data in sandboxes, right? And then you have to, first of all, come up with a reasonable threshold and then apply those tests in the sandbox itself, right? So let's say you are dealing with a lot of complaints. You have an AI system which analyzes your complaints and makes sure that it is a complaint and finds out the next solution step for them. You have to then use real complaints in your sandboxes with masked PII so that you can have a reasonable testing grounds and sandbox around them. And then per execution, you have to track things like successful inference rate, what was the cost for it, how many tries it had to make to get to there, semantic drift, hallucination rate, and the trust delta, right? Every pipeline will come back with a trust delta. And that trust delta is critical to your determinism of your pipeline, right? So those things baked into your CI/CD are very important because your prompt is changing just like code on a daily basis, and your prompt changes could sometimes be exponentially impacting your determinism.
Right. And what production signals, according to you, matter most in production for AI features?
Yeah, so these signals now, everything which we tested for now start mattering in production, right? For example, for us, cost for every successful inference is very important because we are a financial company. We have millions of transactions going through, and a single change in cost can exponentially impact our revenue, for example, right? And the second thing is hallucination rate. Each hallucination into something as deterministic as a fraud analysis causes us money, right? And we need to make sure that our trust deltas are always intact. And then the third part is obviously things around sanity of the whole system itself, right? You you should be making sure that every request has the more or less same deterministic latency around it. And if these things start increasing, if your latency starts increasing, then you are actually impacting transactions. You might be causing attrition to your user base. So these things matter for us, and we monitor them very closely in our production systems.
Right. And how do you set up automated and human feedback loops to improve model stop prompts without breaking user reliable behavior?
Yeah, so feedback is pretty automated, basically, right? Like agent will log all low confidence events and human reviews, and it will relabel. And as I was telling you, prompts are versioned with Git tags. so we can replay failures exactly, right? So because it is an agent, you can always augment asynchronous activities by itself. So what we have today is that every failure in them is then analyzed by a different model so that we don't have model bias itself, right? For example, a failure derived in an OpenAI model will be now reviewed by a Sonnet Claude model, right? And the feedback which we obtain from there will be asynchronously applied to the OpenAI package, right? Which went into OpenAI, the whole thing, right? And we then over time figure out what is working better for us, right? Which model is able to review the feedbacks and failures of a different model, and then we have these model couplings formed by that, and all of it is tracked via Git tags, right? So every release knows has a JSON into it which says here was the analysis and scoring, and here was the recommended prompt changes or guardrail changes, applied it and got this score as the final one, right? So auditability is incredibly important in our ecosystem because this is real data you're dealing with, this is real developers time you're dealing with, and then also sometimes you're dealing with real transactional data. So we need to understand which particular change and then what particular recommendation caused us a transactional benefit across the feedback loops.
Right. And that brings us very nicely into our next segment, where we are going to talk a little bit about data privacy and governance. So, how do you protect sensitive data while keeping AI useful?
Yeah, that's a great topic, and it is at the top of every executive at the moment in the industry, I think. So we basically redact personally identifiable data before inference and use hybrid RAG where private embeddings always stay in house. You know, so for example, we can use something like Pinecone local, where it will be a local instance and private embeddings will always stay in house, and public context is fetched externally in a secure and deterministic way, like a regulatory change, for example, right? Or the impact of regulatory change or human sentiment around a new law, things like that, right? They're fetched in a more deterministic way. And at the heart of all of this is our middleware, right? Where we apply these, like even if you wanted things like sentiment or PII will not flow into the inference layer if we don't want to. So all AI access has been augmented with SAML, which is your authentication. So we know who is accessing it. So we are able to augment their prompt with their role, etc. And then there is a guardrail middleware where we are always applying a particular set of rules based on their role, etc. Right? So even if you accidentally put my email address into the prompt, it will be filtered off before it goes out of the system. And that is where our middleware play a huge role. And we have lightweight governance around whole prompting. So our prompt manifest will define who owns the prompt, what is the data scope, and its safety rating. You can think of a prompt manifest as a Docker file for AI, basically. It is auditable but fast. And finally, for governance, auditability and traceability is paramount for us, right? So we log every inference as an architectural replay. So it will have things like model ID, prompt version, data snapshot. That way, our compliance folks can reproduce any decision path deterministically.
Right. I would like to wrap this section up with what's your take on auditability and traceability for AI decisions when regulation applies?
Yeah, so regulation is paramount, right? I'm dealing with the EU regulation, AI Regulation Act on a daily basis. And basically, it goes back to how deterministic can you make your decision paths, right? So our whole goal is that anytime anything breaks our determinism or that score, we either chuck it out of production immediately or we treat it as a P1 incident, like a priority one incident, right? So any production workflow losing determinism at a given threshold will be treated as a production incident, right? It is no more a developer a playground or anything. And because we are able to log the model ID, basically the architectural snapshot, the replay of it, we are able to log the model ID, prompt version, and the data. we can go back to the decision path and change any of these variables to make sure determinism can be achieved immediately, right? So our ops teams are actually trained to do this thing on a daily basis.
Right. Now let's talk about performance, cost, and vendor strategy. How do you avoid provider lock-ins without slowing delivery?
That's a great thing I've been dealing with recently, Divya. So the thing is, we try to adhere to protocols the market is going ahead with, right? For example, chat completions protocol or API or the MCP, right? These things came from a company to start with, but then they became general practice across the industry. So we abstract the orchestration via these known protocol APIs, right? So when I was talking to you about MCPX, it is basically a multi-provider orchestrator across OpenAI, Azure, Anthropic, and our on-prem models, because all of them support chat completions, responses API, and MCP protocols, model context protocol, right? So now, as long as any publicly available or internal AI provider is following those APIs, we are fine. So then we actually put in an AI gateway. So based on requests in your header, etc., or your SAML information, we can actually route you to a Azure model versus OpenAI model. So that is how we basically avoid lock-in today.
Right. And if we talk about capacity planning and cost control, what's worked for you in terms of caching, batching, smaller models, etc.?
Yeah, so I think the mantra is very simple: cache, batch, distill. We use Tiny Llama for high volume routing tasks and GPT-4 Turbo for design time reasoning, right? So if it is dynamic data like customer support or architecture design, etc., we stay with prompt engineering because in that case, flexibility beats precision.
Okay. And when do you feel training or fine tuning is worth it versus prompt engineering when it comes to a foundation model?
Yeah. So that's a good point. I think if your domain is stable, right, how should I say, maybe KYC or risk scoring, the signals are very well known, the domain is stable. I think we use fine tune. We fine tune, right? Because it's a very well known, stable signal based domain. And as I was saying before, if it is dynamic, if it is changing a lot, uh, Spanish customers complain in a different way. English customers complain in a very sarcastic tone, and Indian customers complain in a very direct tone sometimes and get right. Then we stay with prompt engineering because we have specialized customer people who know how their customers complain and can create prompts more easily to manage those customer complaints, right? So yeah, that's my short answer.
Okay. And now let's zoom out a little bit and then zoom in on the role of an architect itself. What new skills should architects or senior engineers acquire in 2025 and beyond to stay effective with AI in the stack?
Yeah, so architects and senior engineers must definitely learn prompt literacy, model evaluation, and probabilistic reasoning. That's paramount. You don't need to train models. You need to design systems that survive their uncertainty, basically.
Right. And how do you adapt design reviews, ADRs, and incident response for AI specific risks and ongoing learning?
Yeah, so our design reviews have actually brought in a first class citizen in the implementation called AI behavior reviews, right? We have brought it, like, we acknowledge that AI behavior is non deterministic, and we actually use it as a first class citizen of our review process, right? So ADRs capture prompt decisions and fallback strategies, basically, right? And then our SREs have a AI SRE role, right? Someone who understands when it was a drift and not code broke the system, right? As I was telling you, We have trained our ops people to understand the determinism aspect of every AI pipeline. And now they know that it is not the code which broke the system, it was the drift itself in the AI which broke the system, so that they can switch off that pipeline or replace it with something else.
Right. And now, can we extract a short case study in this conversation from you? Can you walk us through a recent AI related technical decision, the options, the trade offs, and how you validated the outcome?
That's actually a very good question. I recently had a very good experience with this. So, I work in a financial company. We have wallets and we usually create wallet workflows on a daily basis. One of my teams was tasked to design checkout experience, right, for a new AI wallet. So we used an architectural agent, which I was telling you earlier about, to design a checkout flow for our digital wallet. This is the same problem I have solved multiple times manually. Back in Apple, a wallet, how checkouts work seamlessly in Paysafe, checkout, etc. So this is a problem I have solved many times, and I knew where I wanted to go, right? The AI itself, I iterated about 5 to 6 times, right? It rejected its own designs when they broke the zero trust rules, right? And finally produced the same mermaid diagram, which I would have drawn if I was starting the design from scratch, right? So it basically took all of my experience of many years into about 35 minutes of assessment, and it was beautifully producing it, that design. And it was basically based on hard constraints, right? For me, consistency was paramount. Partition tolerance was paramount. Zero trust was paramount, and it honored those things. Then we validated it against our standard design templates, right? And it passed every compliance check, right? Right. For example, what if the system crashed at A, B, C? Is the determinism of system and integrity of transaction respected? And it passed every compliance check.
Right.
And the surprise was its persistence, right? As I was telling you, it kept reiterating until all the constraints were met, right? Its initial few iterations would solve zero trust, but not consistency. Or it would solve consistency, but not zero trust. So next time, I plan to pair it with a chaos agent of some sorts to explore failure domains, automatically, and we'll see how it goes.
Right, right. Yeah, looking forward to updates on that. And I want to ask you a few things based on, a conversation we had earlier. Are there any emerging protocols or interface standards you're watching that could reshape how AI components integrate?
Yeah, I think all of this starts from orchestration, right? You can look at these protocols which are coming from PayPal or Google's AP2 protocol or Visa's Agentic Commerce protocol. Everything starts from orchestration. And when orchestration is involved, zero trust is involved, right? And along with orchestration is also involved deterministic fallback, right? So you are an orchestrator. You are orchestrating tasks, right? You cannot trust anyone in the world, so you apply zero trust. And then if that task fails, how do you fall back? So you need workflow engines. And then I am also looking at all the patterns where they are bringing in human in the loop for ambiguity, right? I have had so many use cases where ambiguity is not known until the ambiguity arrives or happens. And I think existence of ambiguity hasn't been mathematically derived as yet. Like, when will ambiguity occur? Obviously, when ambiguity occurs, it's not a mathematical situation. But when will it occur is yet to be known, because systems still operate under the premise of anything can happen, right? So I want to look at chaos agents. I want chaos agents to come into the market and try to disrupt all of the AI workflows. We are so much living in the happy path today, Divya. I'm telling you, everyone thinks that happy path is the only path which happens all through executions. That is not true. Anything can happen, anything can fail. Every design must be explainable by a junior engineer, basically, right? And simplicity is still the ultimate scaling factor. That's all.
Okay, and I think we should revisit this after you finish writing your book and see if anything new has emerged then. So let's do a few hot takes before we talk about your book. According to you, which production metric most correlates with perceived quality?
The trust delta.
Okay, and what's the smallest useful model card or change log for shipped prompts or agents?
So we use Microsoft Guidance, and Microsoft Guidance allows you to basically lets you deal with your prompt as code. So even the commit messages are the smallest kind of change log, which tells you what happened between the two versions of a prompt. So I would say commit messages now.
Okay. Now, looking ahead, what constraints or first principles do you feel keep AI projects grounded? And what will look obvious in 5 years from now about architecting AI heavy systems?
So first principles still apply, as in any AI project will still not break CAP theorem, right? The CAP theorem, when it applies to the determinism of applications, distributed applications, still will apply, right? So you will have trade-offs made when you want consistency and partition tolerance. Availability will suffer, irrespective of human or AI writing the code or design system, right? So those first or an app will be judged by its 12 factor app principles, right? So AI apps are no special. They may be self-healing, but their own app constraints are still 12 factor, right? Zero trust is a model defined to safely execute critical workloads in the world, and that will still continue to apply. One thing which AI will just add is the ability to self heal with ample data and context at hand, which is a great principle we should actually capitulate on and try to create systems which over the time go towards determinism, right? Rather than when they don't, right? And fail fast is still very important, right? If something is not working for you, if determinism is not there, we should fail fast rather than have transactional integrity suffer or our customers suffer.
Right.
Yeah, so I think we have to still, if all the architects were on the same page, we should start versioning and feeding our contexts back into the AI. All the ADRs should go into the AI. The code base should be scanned and understood by the AI on a regular basis. And then we should keep ourselves honest whenever AI tells us that our ADRs and our code bases have diverged, which means we haven't been true to our architectural design, right? That will allow us to have to our AIs to have even more context in the world. And then they can apply these contextual patterns to create any advanced AI system, right? Like any advanced AI system, it will never have, it will still have deterministic models and dimensions, right? It is still working under those same constraints of CAP theorem, etc. So these are solved problems in every nook and cranny of the world. We just have to bring them together in an architectural model, maybe have an architectural model, right? Not just a conversational LLM, maybe have an architectural model out there, and then let it weigh in with you towards your high scale design as a senior architect.
Right. Very, very promising. And now let's talk about your book. You're working on Decode the Compiler. According to you, how does deeper knowledge of compilation or code gen inform how we design AI-driven systems today?
Actually, that's a great question. I'll start with anecdote. So when I was growing up, I read this book called Yashwant Kanath Let Us C++ or Let Us C. And I was taught that when you initialize a pointer or when you allocate a pointer in C using malloc, you must always typecast it to the right variable, right, which you're using. And I kept that in my head. Like it was my first education and it stayed with me until I went into the depths of GNU compiler at Apple, right? The GNU compiler, the Clang, etc. And I realized that I should not be doing this extra typecasting because I am now telling the compiler what to do. The compiler knows what to do. It has seen your system, it has seen your code, however beautiful or ugly it may be. It has known your system constraints. It knows what to do, right? Let it do what it does best. The problem is we don't understand what it does. So how a compiler makes your for loop efficient, for example, or makes your incrementing a variable within a loop efficient, for example, we don't know, right? Many of us don't know that compilers will automatically make some variables as register variables in C and C++. And it is very important for us to know that, so that when we are writing more advanced code, those design patterns can stick with us, right? And that those design patterns we can apply in larger scale habits. In one way, compilers are trying to spoil us, trying to make us lazy, because letting us not take care of those finer performance details by ourselves and doing it on our behalf, which is great. But then we are also losing that sharp curve of learning there. So my book is about understanding from compiler's own output, compiler's own dump of what it has performed, what has it done on your code, right? And you shouldn't be surprised. I think it's basically a very, very interesting thing to learn. Even a simple for or a while loop, how many performance improvements is the compiler making on my behalf, right? And that is what my book is all about, trying to decode the compiler's kindness towards us.
Right. And is there a personal motivation or vision that led you to, make the decision to write this book at this point in your life?
Oh, yes, of course. So when I was at Morgan Stanley and when I came into Apple, I was deeply involved in build and integration systems. I was deeply involved in deep compiler workflows, understanding common build failure patterns. And, I was at the heart of a team which was basically accepting code changes from the entire Apple's operating system developer base inside Apple. So I was seeing these common failure patterns across. And I was like, I wish I could run a podcast and almost every week tell people that this is a very common failure pattern. If all of you do, it is just that it is not well documented. And, sometimes compiler steps in and does it for you and things like that. So syntax failures, sure, compiler will reject you. But the subtle improvement efficiencies which the compiler does, or sometimes we as humans do to make a couple of integrations work correctly, was almost very beautiful for me to just keep it to myself. So I wanted people to understand, when students go into the engineering college today, or their first few C++ programs when they write, they should be surprised to see what is happening beneath the compiler, right? Even if a hello world just comes in front of you, what it took the compiler to do it for you is a beautiful experience I went through, and I want the world to go through that as well.
Wonderful. And in just a few words, who is the ideal reader for this book, according to you? Who will find it to be the most useful?
I think the architects and the senior developers would be the most ideal readers, because they understand, when they look at how compiler optimizes their code, they will be surprised and inspired, right? Those optimizations apply to us in real world architecture as well, right? You would realize that compiler does so many things to scale your token chunking, or to make your lookup faster of a particular data structure. And those are the same patterns which we apply in our day-to-day architecture as well, like when we do caching or when we do streaming of tokens, etc. So senior developers and architects will be inspired. Junior developers and people who are upcoming in the market will be surprised. So it will also apply to them to get surprised, beautifully surprised, flabbergasted, I would say.
Well, that's a wonderful objective to have. And that brings us to the end of our conversation today. Amar, thank you so much for joining us and sharing your rich insights on AI native modernization, agentic systems, and how compiler thinking can inform architecture. It's been really great having you here with us today.
Thanks, Divya. It was great. It was a great, insightful talk with you.
Wonderful. And to our viewers, thank you for watching. If you'd like to go further, follow us for updates on Amar's upcoming book, Decode the Compiler, and keep a lookout for his talks on cell-based architectures and agentic systems. We'll put all the relevant links for you in the description below. Until next time, this is Divya for Deep Engineering.